Regan Slaymaker for Radiant.Green. I have the pleasure to be joined by Met4Tech Research Fellow at the University of Birmingham, Gavin Harper. Gavin, how are you today, mate?
Absolutely brilliant. Pleased to meet you, Regan.
Pleased to meet you too, Gavin. Obviously a bit of a monster event, Solar and Storage Live. You just had your speaking position. How was it?
Yeah, absolutely fantastic. Really interesting panel discussion on EV batteries. Lots of good points there about the end-of-life challenges around batteries, which is something that I specialise in at the University of Birmingham.
Perfect, and we'll get on to that in a minute. But kind of obviously, you've been doing your research, as you've said. But kind of what research have you been carrying out related to solar and storage, and obviously more the battery tech you've mentioned as well?
Okay, so I work on a couple of projects, including the Faraday Institution's ReLib project, which is on the reuse and recycling of lithium-ion batteries, and the Met4Tech project, the UKRI Interdisciplinary Centre for a Circular Economy of Technology Metals, that's the materials in the batteries, and also the TREFCO project, the Thermal Recovery of Functional Coatings. And so a common thread that runs through all of those projects is looking at the critical materials that are contained within batteries, and also, more broadly, you could apply that to the context to solar panels as well, but looking at where we source these materials from and how to keep them in a circular economy, so how to recycle and reuse these materials at the end of life. Perfect.
So kind of obviously we are in a renewable energy event, and obviously recycling is a key part of that. But obviously, I think what things are getting missed. I know the solar panel industry where it's getting missed as well. But we're doing all these great things with solar panels, the developments of it. But when they come to end of life, that's where the issues arise. Kind of how important is a kind of, like you said, one, the circular economy, but two, the recycling of these important and technical materials that are involved. How important is that to make sure this renewable industry is as renewable as it possibly can be as well?
Yeah, I think that's the key thing. We're looking at this zero carbon transition, but let's do it in a way whereby we conserve materials, we really look after those materials, we make the best use of them, and we ensure that we keep them within a circular economy, because that's going to be efficient in terms of materials, it's going to be good for business, it's also going to be good for the environment, because we're not disposing of things in a bad way at the end of life. So I think there's valuable. It's not just looking at it as a waste, it's thinking actually there's a valuable resource there for the next generation of batteries and solar panels. And so it's really thinking about what approaches can we apply to being able to disassemble them, recover the materials, and then put those materials into new supply chains down the line.
Definitely, and I do want to touch on your panel discussion that we just mentioned at the beginning, that you spoke on innovations and improvements in the battery EV technology. Kind of what advancements are being made in this field to kind of contribute to EV batteries being more innovative as well?
So I think from our perspective, looking at that end of life and circularity, there's lots of innovation at the back end on what to do with a battery once you recycle it. Industry at the moment tends to shred batteries up. We're looking at ways that you might be able to disassemble it and recover the materials in a cleaner way. So I think, there's lots of looking at how to deal with a battery as a sort of end of pipe problem once it becomes a waste. I think where there's a real need for innovation and where we really need to see battery manufacturers get on board and pull with the recycling industry is to look at this concept of design for recycle. So what can we do before the battery's even manufactured to design that battery in a way that it makes it easy to process, easy to take apart at the end of life? And I think that there's a lot of work that we can do there on engineering out glues and adhesives and all the things that go into holding a battery together to make it in such a way that it makes it much easier to disassemble at the end of life.
Definitely, obviously there's a huge thing with kind of standardisation there as well, and things like that. But is that kind of the main challenges with that? Obviously, getting that process across the board to all battery manufacturers.
So I think within our ReLib project, standardisation would be really great if it were to happen. It would make it much more simple to recycle things. I think that's unlikely given the amount of applications and the spread that you see lithium-ion batteries in. But we're trying to develop techniques like leveraging robots and AI to be able to identify batteries, sort them, disassemble them more effectively. Trying to use that machine intelligence rather than having to have people pick through piles of scrap at the end of life, which obviously isn't a great job.
No, definitely not. I'd rather be doing this job than doing that, of course. And my final question for you, Gavin, thank you for giving me your time today. Well, we ask everyone in the Charge EV Theatre this question, kind of what, in your opinion, is the key to unlocking mass electric vehicle uptake?
So I think I'm going to flip that around a little bit and say, mass EV uptake, that's other people's challenge. That's not something that I focus on. But what we are focused on is when people do that mass EV adoption, what we're going to do with the wastes that come out of the other end. And I think that, definitely we need to encourage that mass EV adoption, and part of that is going to be through ensuring that the critical materials are available to manufacture those batteries and EVs, but also what we're going to do with them at the end of life. How do we recover those materials? How do we turn them into new products? Because there's going to be a lot of waste to deal with, but that waste is an enormous resource opportunity.
Perfect. Gavin Harper, that was one of the best answers I've had to that question, and it was a bit different as well, and we like different on Radiant.Green. Gavin, thank you very much for your time today, and best of luck. I think we're at the end of the day now, but no, thank you very much for your time.
Superb. Thank
Cheers.
you very much, Regan. Take care.